Today we will learn how to draw a force diagram. In order to understand force diagrams, you'll have to understand what a force is. A force is any interaction that, when unopposed, will change the motion of an object. Units are newtons. Forces are all around us, which is why it's important we know which forces are acting on an object and which forces are not. Force diagrams help us to understand this. A force diagram is a diagram showing all the forces acting on an object. Forces are vectors. A vector is a quantity that has both magnitude and direction. The best way to represent a force is by using arrows to indicate the direction and the magnitude. The magnitude of the force can be indicated by the length of the arrow. The longer the arrow, the bigger the magnitude, the more force. Because forces are vectors, we can calculate how much force is being exerted in each direction. To do this, we find the net force. The net force is the sum of all the forces acting on an object. If the sum is equal to 0, we know the object is balanced. Therefore, the object is not moving or is moving at a constant velocity. This is also known as equilibrium. If the sum is not equal to 0, we know the object is unbalanced. Therefore, it's accelerating. Now let's talk about some of the most common forces seen. Force gravity, represented by Fg. Force normal, represented by Fn. Force tension, represented by Ft. And the force of friction, represented by Fr. As you can see, all these forces have a magnitude and a direction. The magnitude of gravity is m times g, which is mass times gravity. Gravity is 9.81. You can also sometimes round to 10. The direction of gravity is always downward. Force normal magnitude is the projection of the net surface interaction force. Force normal is a little complicated, so later we'll go into more detail. The direction of force normal is parallel to the surface, whether that surface is horizontal or if it's on a slope. The force of tension is equal to the weight of the body suspended by the string, and the direction is along the rope. The force of friction can be calculated by using this equation, and the direction is opposing motion. Now, let's get into better detail about force normal. Force normal is a support force exerted upon an object that is in contact with another stable object. So basically, force normal is a force between two objects on a surface, whether that surface is horizontal or on a slope. Now that you have a better understanding of how force diagrams work, let's try some examples. Our first example is a book is at rest on a tabletop. Diagram the forces acting on the book. Well, here's our book, and it's lying on a horizontal surface. Now let's go through our chart. Force of gravity, well, we know force of gravity is always working. So we draw force of gravity working downwards because that's the direction, and we label it force of gravity. Force normal, this is a force between two objects, and the force is on a surface. So we draw an arrow parallel to the surface and label it force of normal. No force of tension because I don't see any strings, and no force of friction because nothing is applying force onto this object. So this would be our force diagram. In our second problem, it reads, a gymnast holding onto a bar is suspended motionless in midair. The bar is supported by two ropes that attach to the ceiling. Diagram the forces acting on the combination of the gymnast and the bar. So this time our object is a combination of the gymnast and the bar. That doesn't make it any different. We can just say our object is a lot bigger. Now we know that two ropes are suspended. Ropes should automatically attract you to force tension. So we know that these two ropes are a force of tension. And we know force of gravity is always working on every object, so force of gravity is working downwards. There is no force normal because this object is suspended in midair. It's not on a surface. And there's no force of friction because it's not being pushed or moved against the surface. So this will be your complete force diagram. In our third example, a rightward force is applied to a book in order to move it across a desk with a rightward acceleration. Consider frictional forces, neglect air resistance. So in this problem, we have our book and it's on a horizontal surface. Just like in the first one, we have a force of gravity working downward and we have a force normal working upward. But this time, we have a different force, an applied force. Now I know this wasn't in our chart, but it's pretty explanatory. Force applied to the right. We are applying a force to the right, so it's force applied. And it also says to consider frictional forces. Friction is when two objects or surface in an object encounter each other, and one is moving over another. So friction is in the opposite direction of the applied force because it's opposing the applied force. So we have frictional force in the left direction. No tension, so this would be our complete force diagram. Now let's see if we can go back to all of our problems and calculate the net force. In our first one, it's a simple diagram. Now, we can tell right by the word problem that this is a balanced force because the book is at rest. It's not moving. Nothing's moving it. It's just sitting there. So, from that, we can say that these two forces are equal to each other. One in the positive direction, one in the negative direction, making the total 0, a balanced force. In our next problem, it says that the bar is suspended and motionless in midair. Same thing as at rest. Nothing is moving it. Therefore, the force of tension and the force of gravity are also going to balance each other out and be equal, adding up to a net force of 0, a balanced object. In our last one, it's a little different because we have a force applied. Now, I know you say that the force of gravity and the force normal, well, those should still be the same. Well, they are. These two will cancel each other out in the y direction. So the book won't be moving in the y direction. But rightward acceleration. Acceleration is a key word in unbalanced. That means that this object is being accelerated to the right. So rightward acceleration is going to be more than the force of friction. Therefore, this is not going to equal 0. We don't know what it equals because we don't have numbers in the equations. But if there were numbers, we would certainly be able to figure that out. But for all we know right now, this is an unbalanced force diagram. Thank you for learning with me today. I hope you have a better understanding of how to draw force diagrams.